Before you can understand what the Internet is, you need to understand what a network is. A computer network is any arrangement where you have multiple computers all connected to each other by some means, such that each computer on the network can send data to any other. In our diagram here, we have a network of several computers, each computer represented as a little white square. And in the terminology of networks, we usually call a computer a host. Quite importantly in the definition of a network is that it is something owned and operated by one entity, one person or one organization. All of the systems on the network, all of the hosts, and the means to connect them are all controlled by one entity. When we take multiple independent networks and connect them together into one larger network, we call that an internet. Not necessarily the internet, just an internet. An internet is effectively a network of networks, and the connection points between the networks are these special hosts called routers. A router is a computer which acts as a connection point between two networks, and the data from one network to the other is passed through those routers. So here in our diagram we're depicting three networks, one green, one red, and one blue, and the circled system here is the router connecting the red and blue networks. The purpose of an internet is really just the same as a network. We want all of the systems on this internet to be able to send data to any other. So, for example, if I wish to send data from this host on the red network to this host on the green network, then the data can get there by passing through the router which connects the two networks. What we call the Internet is the global worldwide Internet. It's the Internet to which most computers in the world now are connected. You may be wondering, how can you get all of these disparate networks, these thousands of networks around the world, to connect to each other and interoperate? Well, the answer is that they use a standard protocol called IP, which stands for Internet Protocol. In the IP protocol, data is sent in packets, meaning it's sent in discrete chunks of about, say, 1,000 bytes or maybe more. And just like a letter or package making its way through the mail system, a packet is copied from one router to the next until it reaches its destination. Now, of course, when a computer sends a packet, it needs to be able to specify where the packet should go. Which computer on the Internet should be the recipient. So for the Internet to work, each system on the Internet needs to have a unique address. And currently, these addresses are 32 bits in size. And because 2 to the 32nd power is something over 4 billion, we have that number of unique addresses available. So currently, at most, we can have a little bit over 4 billion computers all connected to the Internet at once. The way you see these addresses written is a little bit peculiar. 32 bits is 4 bytes. 32 divided by 8 is 4. And an individual byte can be expressed as a number between 0 and 255, so we write these 4 numbers separated by dots, and that's an IP address. So for example, an IP address will look like 233.75.19.198. Notice that all of those numbers are less than 256. Now, as a user, you generally don't have to directly deal with IP addresses, but you'll occasionally see them around, so it's nice to recognize them. In any case, imagine a scenario where you go onto the Internet to order something from Amazon.com. Amazon is an online retailer. For such a transaction to take place, there of course has to be communication between your computer and a computer belonging to Amazon. Well, first off, of course, both of you must be connected to the Internet, and what that means is that you pay a local service provider, an Internet service provider, to allow you to connect your computer to their local network, a network which probably spans just your citywide area. Amazon, in turn, must do the same thing. They need to connect to an Internet service provider in their area. And notice in the diagram, when you connect to your Internet service provider, your system becomes a part of that network. Now, if you and Amazon are located somewhere near each other, it may be the case that their Internet service provider's network and your Internet service provider's network are directly connected to each other. More likely, however, there's some number of other networks in between your network and theirs. And so for a packet to reach from your computer to Amazon's computer, it has to get copied from router to router until it ends up on Amazon's computer. And note that there isn't necessarily just one path through all the routers to get to the destination. Even in this relatively simple situation in the diagram, there are actually 2 different paths which the packet can take. the packet might take the shortest route going directly through the green network, or it might first go to the blue network before going to the green network. One of the most interesting aspects of the internet and the crux of its design is that when you send a packet, the plan for how that packet's going to reach its destination is not worked out ahead of time. Instead, whenever a packet arrives at a router, it's really entirely up to that router to decide where it should go next, and eventually the packet should reach its destination. Now, you may be wondering about all of these networks in between. It doesn't seem to make sense economically. My internet service provider is willing to bear my traffic because I'm paying them money. And similarly, when I send a packet to Amazon, it makes sense that that internet service provider is willing to take that packet because Amazon is paying them money and they want to get that traffic being sent to them. But what about the backbone networks in between? Why are they willing to take the packet from my internet service provider and send it on to Amazon's internet service provider? It's a common misconception that they do it for free or that they are somehow government subsidized. That is not the case. Very simply, when my internet service provider sends a packet through an adjacent backbone network, my service provider pays them money. And really, just like with letters and packages, the general rule is the sender pays. That actually explains why the typical internet connection usually allows you to download data, receive data, faster than you're allowed to upload it, to send it. Because it costs your internet service provider a lot more money when you send data rather than just receive it. Lastly, you should have a rough idea of what this looks like in the physical world. Let's say that you're located somewhere in the Los Angeles area and Amazon is located somewhere around Seattle. Amazon's service provider network and your service provider network, they most likely span relatively contained regions, say a radius of 5 miles or so. The backbone networks typically span much larger regions, like say from state to state. What's depicted here is rather simplified. It's much more likely that for a packet to get from Los Angeles to Seattle, it has to go through several backbone networks rather than just one. So say it's very likely that a packet here would get routed through San Jose and then through Portland before going on to Seattle. When you get cable internet service from your cable company or DSL internet service from your phone company, your setup at home should look something like this. First off, the cable or DSL line that comes out of your wall needs to run into what's called a modem, which is the device which is actually immediately connected to your internet service provider's network. When connected, your modem is the device which is given a unique IP address. Now, using an Ethernet cable, you can directly connect your computer to the modem, but this is generally a bad idea. Instead, what you should do is use an Ethernet cable to connect your modem to another small device called an access router. Confusingly, these access routers are commonly just called routers, but they're really not like routers like we previously discussed. What an access router allows you to do is to share your single internet connection among multiple devices, multiple computers, and maybe other things like, say, your phone or your Xbox and other such things. To connect devices to the access router, you can use Ethernet cable, though almost all access routers these days are also wireless, so if your device supports a wireless connection, you can just use that. Now, even if you just have one device you wish to connect to the internet, you still should use an access router for reasons having to do with security, which we'll talk about in a later unit. We've said that the goal of a computer network is to allow computers to send data to other computers, but in truth, the goal of a network is to allow programs running on those computers to send data to other programs running on other computers. When we talk about programs that make use of the network, we divide them into two broad categories. A server is a program which primarily listens on the network for requests coming from other programs, and the server then responds to those requests. A client, in contrast, is a program which makes requests. So, a client sends a request to a server, the server is listening for that request, and when it gets a request, it returns a response to the client. Somewhat confusingly, you'll often hear people use the term server to describe a computer system, not a program. A computer, which we call a server, isn't really special hardware. It's just a regular computer, except we're using it to act as a server. The main thing it does is it runs a server program. For example, in this picture here, this computer was mainly used as a server, and someone has written on its front, "This machine is a server. Do not power down." That's fairly typical. When you run a server, you generally want it to run 24 hours a day, and so you just leave it running all of the time. Now, the obvious problem with IP addresses is that they are numbers, and numbers just aren't very human-friendly. They're hard to remember. And so, the DNS, Domain Name System, was invented. The DNS system is a system of resolving names, like yahoo.com, to IP addresses. Names in the DNS system are organized into what are called top-level domains. The most popular top-level domains include com, net, org, edu, which is short for education, mil, which is for military, gov, which is for government, and then you have some country codes for various countries like UK for the United Kingdom, CA for Canada, DE for Deutschland for Germany. And the idea behind these top-level domains is that each one is controlled by a designated authority. In the case of the country codes like UK, it's fairly obvious who controls that. UK is controlled by the United Kingdom government. Gov is controlled by the American government, Mil by the American military. EDU is controlled by an assortment of various educational institutions. And in the case of com, net, and org, the authority has been designated to a number of companies. The idea with most of these top-level domains is that the authority which controls that top-level domain will allow other people to register a subdomain for a price. For example, google.com is a subdomain of the com top-level domain. Google pays money to the com registration authority to allow it to have the name google.com. Registering these subdomains is fairly cheap these days. You can register a name for a year for less than $20. But of course, you're limited in that you can't register a name which has already been registered. Google.com is taken, so I can't register the name google.com. The purpose of registering a domain name is that for every domain name you control, you get to determine which IP address it resolves into. So for example, Google controls google.com, so they get to decide which IP address google.com resolves to. Presumably, they'll have it resolved to the IP address of their server, so that when people look up google.com, they will be directed to Google's server. Now, when a program on your computer wants to know which IP address does google.com resolve to, it needs to ask what's called a DNS server. A DNS server is simply a program which listens for requests asking what does this domain name resolve to, and it responds with the answer. Now the problem is it wouldn't work for everyone in the world to use the same DNS server. You can't have one server responding to millions of requests per second from all over the world. So instead, typically, computers are configured to use a DNS server run by their internet service provider. The question then is what happens when a new domain name is registered, or what happens when an existing domain name changes its IP address. Ideally, what we want is for all the DNS servers in the world to be instantly updated with that new information. In practice, what happens is that every domain name server in the world periodically checks for new updates from a central authority, like say the people who control the .com domain. And so there is some lag in the system. When you register a new domain name or change your domain name, it could take a day or so before every DNS server in the world has been updated with that new information. What we call a URL stands for Universal Resource Locator, and it is a standard way of designating some sort of resource, some thing, on the internet. It's just some piece of text that designates something like, say, a web page. Each URL has three parts. First, what's called the schema, which designates the nature of the thing being referenced, and then after a colon and 2 slashes you put the host, in other words, the location of the resource, as specified by an IP address or a domain name, effectively the computer on which the resource is located, and then after another slash you put what is called the path, and the path is simply some piece of text which specifies which resource on that host, because of course a single host can have many resources. So for example, here's the URL of a web page on the New York Times website. The schema used for web pages is HTTP, as we'll discuss in a moment. The location here is specified by the domain name of www.nytimes.com. That's a domain owned by the New York Times, and it resolves to the IP address of a computer owned by the New York Times. And then after the domain name and a slash, you see this whole sequence of text of 2010/08/world/asia/08afghan.html. All of that is the path. It specifies which page at the New York Times this URL designates. In this case, the path looks a lot like a file path, but it doesn't necessarily mean that we're requesting a file named 08afghan.html inside the directories 2010/08/08/world/asia. Now, that might be the case, but it isn't necessarily the case. It's really entirely up to the computer at the New York Times to determine what this path specifies. So you may often see URLs where the path looks like a file path, but there's no necessary connection between file paths and URLs. Lastly, notice here that the URL doesn't have any spaces in it. URLs are not allowed to have spaces. It's very likely you've heard about the web and not understood what people mean. Often in the last 15 years, the term web has been used interchangeably with the internet itself, but they're really not the same thing. What we call the web is not synonymous with the internet. It's just one part of the internet. It's one thing we can do on the internet, and it's a system involving basically two parts: server programs called web servers and client programs called web browsers. As a user of the web, you use a web browser, which is a program which displays web pages. These web pages are documents in a format called HTML, which stands for Hypertext Markup Language, and your web browser retrieves these documents from web servers using a protocol called HTTP, which stands for Hypertext Transfer Protocol. That's why a URL for a web page begins with the schema HTTP. Now, be clear that HTTP does not supplant IP, the Internet Protocol. Everything on the Internet uses IP. It's just in this case, we're packaging another protocol within our packets of IP data. So think of it like an IP packet is an envelope stuffed with another envelope inside, an HTTP envelope. In any case, a web page, an HTML document, is a document that can include first formatted text, meaning text that has different fonts and has different sizes, different colors, italicized, bold, and so forth. And also the documents can contain images, so they're not strictly textual. And then, very importantly, an HTML document can also include links. The idea of a link is that you can have a piece of text or an image which is clickable, and when you click that link, it takes you to another web page. So, for example, here's a very simple web page with some text, a link, and an image. The link here is the text which is highlighted in blue and underlined that says, "Do you like ducks?" And the idea is that in the document, that text is associated with a URL pointing to some other document out there on the web. And so when the user clicks on this link, their web browser then retrieves the web page at that URL and then displays it. So it's called hypertext and the web because within a document you have things you can click which can take you to other documents. Aside from text, images, and links, you can have a few other things in web pages, what we usually call form widgets. Widgets, recall, is the programmer jargon term for various things you commonly see in programs like pull-down menus and text boxes where you can type. So you'll see a few of those things inside web pages, and the idea is that the user can type something in, say, these text boxes here, then click the button, and that makes a request to a web server in which that information in the text box is also sent. And this is actually one way in which web pages can be more interactive than just being a bunch of static documents. This is actually very important to understand. In the very early days of the web, back in the mid-90s, almost all web pages were just totally static. Someone would author the page, and then when anyone visited the page, they would get back exactly what was authored. Very quickly, however, people hit upon the idea of dynamically generated pages, meaning a page which is of course designed, but then programmatically, every time a request for that page is made, the server fills in certain details. In effect, the web server ends up generating the page every time someone visits it. And this opens up possibilities for much more interesting websites. Things like, say, a web store would not be possible without dynamically generated pages. Here, for example, is Amazon's website, And when I visited this website, I logged in with my username and password. And so you can see up in the top left of the page, it says, "Hello, Brian Will." It has my name. Obviously, no one hard-coded my name into the web page. It was dynamically inserted into the page by the web server, because once I logged into the website, the web server knows that this request for the page was coming from me, and so it can customize the page for me. For example, down here at the bottom where it shows 5 albums, those 5 albums were put in the page here because statistically Amazon has determined they're the sort of thing that I might like based upon my previous purchase history. So it's good to have some mental model of what might be happening when you visit a website. For a lot of websites these days, you have to provide your username and password, and then any subsequent page you request from that server, the server knows who you are. They've kept track of you. They probably have some information about what you've done in the past, like say on Amazon, they have information about what I ordered in the past. And so when they serve you web pages, it can be customized based upon that information. So you may be wondering, how do you find anything at all on the web? What if you don't even have an idea of what's available, let alone how to get there? Well, that's where you use a web search engine. Web search is a service offered by a number of companies, primarily Google, Yahoo, and a service from Microsoft called Bing. The way this works, for example, is that I go to Google's web page, and for that I just have to remember that their address is http://google.com, and on their web page they have a text box where I type search terms, things I want to search for, and then I click the button that says search, and that takes me to a page that shows search results for what I entered. So if I enter the text ducks and click the button, I'll get back this page with a list of links to web pages about ducks. How this works is that Google has machines that do nothing but spider the web, meaning it goes out to random pages, it follows all the links on all the pages it can find, and as it does so and retrieves these pages, it makes a textual index of all the text on all those pages. Now, it turns out the real tricky part is deciding in which order to display any relevant results. Like in this case, when I search for ducks, it turns out that Google has 14.5 million different pages that match the term ducks. And Google has to decide which of those 14.5 million pages I most want to see, which ones should go at the top of the results. In general, Google and the other search engines try and order their results by popularity. So generally when you see a link at the top of the results page, it's because it's a popular link. Now, you may be wondering, how do they make money from providing this service? Well, the answer is that they sell advertisements. When you look at the Google's results page, that column off on the right, you'll see in faint gray text at the top, it's labeled Sponsored Links. That whole column off on the right, those are advertisements. Advertisements which do have something to do with what you searched for, but these particular links you're seeing because someone paid money, not because they are necessarily popular. So far, Google and the other search providers try hard not to mingle advertisements with the proper search results, because they know that users want to see search results that aren't contaminated with pay-for-play. When I search for ducks, I probably want to see at the top of the results an informative page about ducks, not a page that's trying to sell me something. For most users of the web, there are sites which they go to over and over again, and so browsers have this mechanism called bookmarks for keeping track of websites you have visited before. When you're looking at a web page that you know you'll want to come back to later, you can click on this little star icon to bookmark that page. The bookmark is simply a record of the title of that page and its URL, and so you can get back to a page by clicking on a bookmark in your web browser's list of bookmarks. However, you must understand this won't necessarily take you back to the page exactly as you saw it. As I explained before, many web pages these days are dynamically generated by the web server. And so when you have your browser go to the page at a certain URL, the web server might change what page it sends back every time that URL is visited. Something might be changing on that page. Now, if there's some page that you really want to make sure you can preserve so you can get at it again exactly as it was, it is possible to save a page to a file so that you can open it later from your local system. And that ensures that you can get back to a page, even if it's taken down from the location where you found it. So the web is the part of the internet which people spend most of their time with, but it's not the whole internet. There are other things we can do with it, including email. Email is a separate application from the web. In fact, it doesn't use HTTP, it uses these other protocols, SMTP, POP, and IMAP. To send and receive email, you need an email address. And these addresses have the form of a username followed by the @ symbol, which looks like an A with a circle around it, and then a domain name. The domain name is the part of the address which specifies where an email message should be sent to on the internet, and the username specifies the recipient at that location. The way this system works is you need both email servers and email clients. The servers are responsible for actually sending the messages and storing any received messages, and the clients are the programs which users actually interact with on their own systems. So, for example, here in this diagram, when Nathan@apples.com wishes to send an email to Kate@orange.net, Nathan composes the message in his email client, and then his email client sends it to his email server, and that email server sends it to Kate's email server, and the email sits on that server until Kate checks her email with her email client. Typically, when you sign up for internet service, your service provider gives you an email account on their email server, and then you can interact with that account using an email client on your own system. Two popular email clients include one from Microsoft called Outlook and a free one called Thunderbird, which is made by Mozilla, the same people who make the Firefox web browser. Rather than using an email client, however, many people these days simply use what is called webmail, which is pretty much what it sounds like. It's doing email using your web browser. For example, Google offers a webmail service called Gmail. If you go to the Gmail web page, you can sign up for an account and pick an email address. Then, when you go to the Gmail web page and sign in with your account, it'll take you to a page where you can read your incoming mail and send new emails. So Gmail is probably the most popular webmail service right now. Another popular one is Yahoo Mail. So the web and email are the most popular things for users to do with the internet, but there are of course other applications like, for example, games, and also instant messaging is very popular, and also this thing called VoIP, V-O-I-P, which stands for Voice over Internet Protocol, meaning basically you can make phone calls over the internet using a microphone with your computer. And a popular program for that purpose is one called Skype.